we're going to cover chapter 8 in this. You will need a graphing calculator. If you don't have a graphing calculator, I posted, or I sent you guys a message, and then there's also a document, PDF, I think, on our Canvas main page with a couple ideas on how to get the graphic calculator on your phone. So you can look there. You can use either of those apps depending on if you have Android or iPhone. Or I also posted a link to download the TI-84 simulator that I use in class on the desktop. You can do that on your desktop as well. So if you happen to not have a TI-84, check Canvas for those links, and you can find the correct one for whatever your situation is. So chapter 8, we're going to cover correlation. Correlation, you guys have talked about correlation in the past, and the main thing you probably remember is correlation is not causation, or association is not causation, and we've talked about that quite a bit. We're going to continue talking about that today. So these are just the objectives. Make sure you have your slides printed out. Again, you can get those slides on the Canvas page. So print out the chapter 8 and 9 slides. I'd recommend printing them 6 to a page. You can do 4 to a page if you prefer more space though. So make sure you have these slides and read through those objectives at some point, so you just make sure you know what we're covering. So with correlation, we need to look a lot at scatter plots or scatter diagrams. They're called both. So a scatter diagram shows the relationship between two variables. For example, this X right here, it shows one specific father-son pair. So what this graph is showing is it's the father's height along the x-axis and the son's height along the y-axis. So this point right here is representing a father-son duo that has a father's height of maybe 72, 73, probably 73, and a son's height of whatever that number would be, 76 probably. Oh, look, it says it right here. I could just read this. So a father who's 72 inches and a son that's 76 inches. Each of these different x's here represent one specific father-son duo. And what we're looking at is a scatter diagram of several different pairs, and we can see that as you graph those points, there's a trend to those points, and that trend is going uphill. So generally speaking, as a if a father is taller, the son typically is taller as well. So there's that correlation there between father's heights and son's heights. This shows more examples. So this one just had a few X's on it. This one we've got a bunch of dots where we have the father's heights and the son's heights all graphed there, and you can see, generally speaking, it does go up. As the father's height increases, so does the son's height. That's not saying for each individual person, that's saying in general, as father's height increases, so does son's height. Okay, so we can look at all fathers who are 72 inches tall. So that's this bit right here. All of the dots in here represent a pair whose father is 72 inches tall. And then we've got a bunch of dots in here that show the son's height as well. So with the son's height, we've got everything down here from 64 inches all the way up to 74 inches. But most of them fall within this range. So we're going to say the son's height is between 66.5 and 75.5. We've got one outside here, but most of them are within that range. This shape right here, we're going to call it the football shape. And it's going to be our general shape for scatter diagrams. So you're going to hear me say the word football shape or words football shape quite a bit. With our scatter plots in this chapter, we are going to draw that football around it, and that football is going to show whether the scatter diagram is going up or going down. And then it's also going to show how correlated it is based off of how fat or skinny that football is. This right here represents just this specific 72 inches. That's what that line is showing. So we have this where the father's height is going up as the son's height goes up as the father's height goes up. The association is what we were just looking at, how the son's heights act as the father's heights go up. And in this case, it was going up for both of them, so it was a positive association. So positive association is as one variable goes up, so does the other. A negative association is as one variable goes up, the other one goes down. So as one variable goes up, the other one going down. So those are our two options. Positive has a slope of a positive number, or it's going up. Negative has a slope of a negative number, or it's going down. And then there's also strong association versus weak association. And what that shows is how correlated it is. So almost always, as one goes up, the other is going to go up, or generally speaking, as one goes up, the other goes up. That's the difference between strong versus weak. So this one, strong, is going to be almost an exact straight line. And we can see that with this football, it's very flat. Versus this one, a weak association, is the dots are more spread out, so our football is going to be a bit fatter. So we've got a flat football versus a fat or normal sized football. With strong, knowing one variable helps predict the other variable quite a bit, versus weak, knowing one doesn't help as much with predicting the other because there's not as strong of an association. So that's the difference. That's why we're going to need to know when it's strong versus when it's weak, so we can know how to use those associations. We've got correlation here. So correlation is the same thing as association, and I'll switch back and forth between those two words. And we use the letter R, R, to represent correlation. I don't know why they chose the letter R, but it's what they did. Correlation is always going to be between -1 and +1. 0 correlation means very loose or weak. Clustering near 1 means very strong clustering. And you can see that based off of these football shapes. This is a very small football. This is a very flat football versus a very fat football. Quick comment on this. When we're talking strong versus weak, we're talking the absolute value of the correlation. So a -1 correlation is just as strong as a +1 correlation. A -0.2 correlation is just as weak as a 0.2 correlation. So when we talk correlation, we're talking the absolute value of R. So strong or weak is based off how, or the absolute value of R, or how fat or flat the scatter plot is. Okay, so we just talked R goes in between -1 and +1. And you can see some correlations there. -1 or +1, all the dots are on the line. It's a perfect correlation. The line you draw that follows the trend of the data is hitting every single dot. So that's -1 or +1. 0, there is no correlation at all, no pattern to it. You can't say as one goes up, the other one goes up or down. It's just the dots are everywhere. -0.7 looks like this, and +0.7 looks like this, and that's actually the halfway point. Rather than 0.5 being the halfway point, which would make sense, they use 0.7 as the halfway point. So if something is 0.7 for correlation, it is half strong, or like right in the middle. It's not strong, it's not weak, it's just right there in the middle. So you would call moderate correlation is the word you'd say there. So we just said R is always between -1 and 1. And then we talked R is -1 means negative slope, +1 means positive slope, and it's exact line if it's 1 or -1. Okay, on this one, it says in each diagram there are 100 points with an average of 3 and an SD of 1, both horizontally and vertically. The correlation coefficient R measures the amount of clustering about the line. Okay, this first sentence here, don't worry too much about it. We'll learn more about what that means here in a few minutes. But for right now, you don't need to know what that means. What we do need to do is estimate the correlation coefficient for each of these. So I'm going to give you guys some options, and before I show you the answers, I want you to guess what the option, or which one matches which. And don't look at the next one, because it doesn't give you the answers. Okay, so we've got 0.9, 0.6, 0.4, 0.8. Oh, that's funny. I should probably look when I write on the board. And it tells us this one is 0.95. If you printed that out on 6 per slide, that's probably pretty hard to read. So that's a 0.95 correlation, meaning it's almost perfectly one, or almost perfectly straight line. And if I draw a line following that trend, you can see the dots are really close to that line. Versus 0, there is no correlation there at all. So this one that I'm writing on is no correlation. This one is very strong. And then the rest of these, we just need to line up their correlation with their clustering, how weak or strong the clustering is. So take 20 seconds and assign each one what you think it is, and then we'll double check. Okay, 0.9 is going to be the strongest one. So we can see out of all of these, it goes in order. So it should be pretty easy to do it. That's a pretty flat football. 0.8 is this one. 0.6. Oh, well that didn't work very well. 0.6 will be this one. And 0.4 is this one. And remember, 0.7 is your halfway point. So that should be what like a normal football would look like. You can see this one's a little bit fatter than a normal football. And this one's quite a bit fatter than a normal football, versus this one's a little bit too flat, and this one's very too flat. Okay, so you can check your answers here. Here are the same scatter diagrams with the oval showing the main portion of the cloud of points. So we just drew that on the last slide. You can see when we draw these, there's a few points that are outside the football, and that's okay. You just want the general shape of it, so you don't have to hit all of the points. Positive association is indicated by a positive sign in the correlation coefficient, or that just means each of these numbers are positive. There's not a negative sign on them. So as the x variable increases, so does the y. As r gets closer to 1, the points cluster more tightly around the line. Okay, do the same thing on this one. These are all negative correlations. And let me give you your options, and you can check them. Okay, so your options. I gotta find the right slide. There we go. Negative 0.9, negative 0.5, negative 0.7, and negative 0.95. So match those. You've got 20 seconds to do so. That probably wasn't 20 seconds, but I'll bet you're done already. I'm going to start at the bottom and work my way up. So this one is almost a perfectly straight line, and you can see it's a very, very strong correlation. If I draw a football around this one, that's a pretty flat football. So I'm going to use negative 0.95 here. And then this must be negative 0.9 because that's my next option. Negative 0.7, remember that's our halfway point, so that should look like a pretty normal football. I don't know if it does, but it should. And then this is negative 0.5. If I draw a football around that, it looks generally like that. And negative 0.3, it's not quite 0. There is a little bit of a trend to it, but it's pretty big football, or pretty fat. Okay, same thing on this one. Main thing you need to know from this, negative association as y decreases, x increases, or vice versa. So as x increases, y decreases. Did not mean to cross that out. Whoops. Okay, on this one, can't really think fair share because it's just you by yourself, I assume. Just match each of those, and then we'll check them in about 10 seconds. Okay, this is basically a perfect line. So I'm going to call that 1, especially because it's positive. Notice we do have negatives and positives here. If I draw a football around the general trend of that, it's pretty much 0, but I don't have 0 as an option. It shouldn't be exactly 0 because it does have a positive slope. So I'm going to say, let's see, between these two, this one has a positive slope, so it's 0.27. Okay, this one looks like a negative slope, so it must be the negative 0.2. This one has a negative slope, and it's pretty flat when I draw that football around it. So I'm going to choose, let's see, I've got negative 0.93 versus negative 0.75. It doesn't look like a straight line to me, so I'm not going to use the negative 0.93. I'm going to use the negative 0.75 on that one. Okay, a couple more options. This one, it's pretty normal looking football, so it can be close to 0.7. So 0.63 is my option there. There's only one option left, and we can see this one is a really flat football. I can draw a line through it, and it hits pretty close to all the dots, so it must be that negative 0.93. Okay, this one says, which is stronger, or correlation of 0.5 or negative 0.9? When we're talking strong versus weak, we are talking the absolute value of R, so that means you drop all negative signs. So really it's saying 0.5 versus 0.9. 0.9 is stronger. So negative 0.9 is going to be a stronger correlation. Okay, if the scatter diagram is football shaped, it can be summarized using a 5-number summary. And we're going to refer to this 5-number summary a lot throughout the rest of the trimester. So you'll definitely want to pay attention to this. The 5-number summary is the average.
Teachers, we have CTE department, the arts department, PE department, and special ed department. Come down to the lecture hall for our 9 o'clock faculty meeting. CTE, arts, PE, and SPED. Thanks.
Sorry about that interruption there. It's like you're back in class, isn't it? Okay, so our 5-number summary, we've got average X and SD of X. Remember, standard deviation is what SD stands for. Average Y, standard deviation of Y, and then R, or our correlation, which is what we've just been talking about. How strong or weak those dots are clustered together. When you've got a football, the point of averages is going to be the middle of the football. So this point right here, the middle of the football, is the average of X, average of X, and average of Y. So I'm always going to call that the point of averages. Oh, I don't have to write it because it says right there. Okay, that will always have to be in the middle. And then you're going to take that middle and draw out 2 standard deviations away from the middle. And that should be at the edge of the football. So that's what we see here on our next one. If we take the middle and go out 2 standard deviations, that is basically the edge of the football. So we have our middle point right here, 2 standard deviations to the right. So if I know the standard deviation is 10, 2 standard deviations would mean this distance is 20. And 2 standard deviations to the left gets us to basically the edge of the football to the left and the right. So that's our standard deviations for our x's, because that's going left and right. You can also take your point of averages and go 2 standard deviations above and 2 standard deviations below to get the edges of the football vertically as well. So that's going to be your y, because that's the vertical standard deviation. With this 5-number summary, you will be able to sketch the scatter diagram if you're told the 5-number summary, and you'll also be able to go backwards, approximate the 5-number summary from a scatter diagram. So what that means is I'm going to give you this 5-number summary. I'm going to tell you the numbers for each of these, and you're going to be able to draw this football, what it should look like, based off of those 5 things. So let's practice it. We've got the midterm. It's just a little smaller. Okay, the midterm and final scores. And we're going to say the midterm is X, the final is Y. Typically, the midterm will be given to you on top, and the final will be given to you on bottom. Or sorry, the Y value will be the bottom, the X value will be the top. If it's otherwise, it will specify. So we are predicting the final score from the midterm score, basically. We're using the X value to predict what the Y value would be. In this case, we know them, so we're just plotting what we know. We have our 5-number summary, the average of the X, the standard deviation of the X, the average of the Y, the standard deviation of the Y, and our correlation. That tells us how big the football should be. So it's 0.7, so it should just be like a normal looking football. And it's not super strong, it's not super weak, it's just moderate correlation there. Okay, I'm going to start with the point of averages. So when I want to draw this, I start with point of averages. The average of X, average of Y, and that will be the middle of my football. Okay, that point of average is 80, 75. So I'm going to plot that. 80, ooh, that was crooked. 75. Okay, there's my point in the middle there. Oh no, that didn't work. Okay, I'm going to make a note to myself that that is the point 80, 75. So that's step 1. Step 2 is to use your SD of x and go 2 standard deviations for x, and then negative 2 standard deviations, negative 2 standard deviations for x. So we're going to go, let's see, 1 standard deviation is 8, so 2 standard deviations is 16, negative 2 standard deviations is negative 16. So that means we're going to go 16 each direction from the middle. So this middle is at 80. It's supposed to be. Okay, so 16 to the right of 80 is 96. 16 to the left of 80 is 64. So I'm going to go to 96 and 64. And I know those 2 lines will represent pretty close to the edge of the football. Okay, then I need to do step 3. The 2 standard deviations for y and negative 2 standard deviations for y. The standard deviation for y is 10. So I'm going to take my average for y, which is 75, and add 2 times 10 is 20. Get 95. Standard deviation minus 20, or sorry, average is 75, minus 20 is 55. So that gives me the edges of the football vertically. It's going to be 55 to 95. Okay, the last thing, step 4, which I guess I'm going to write over here, because that's where I remember, is to use correlation. We know the correlation is how fat or flat the football is. And we already said, since R is 0.7, it's just a normal looking football. So it's not really fat, it's not really flat. It just looks approximately like that. So let's just say for a minute that the correlation was like 0.9, then you would draw something like this. That would be if it said 0.9. So that's not what it actually is. I'm just showing you in case you ever see that in the future. If it said the correlation was something like 0.2, you do something more like this. That's almost a circle, but it does go up. So that's the difference there with the football shapes. Okay, you can also go backwards. So we were able to take our 5-number summary and use these 4 steps here to create our football. But we can go backwards and use our football to find the 5-number summary. So when we're going backwards, first step is going to be to draw the football. And when you do that, that will give you R. So when I draw my football, I want to hit most of the points, if not all of them. And that looks like a pretty normal football to me, so I'm going to say that's approximately 0.7. This is just an approximation. It doesn't have to be exact. Your football doesn't have to look the same as mine. Your football might be a little less lumpy than mine. That's probably a good thing. If you say 0.6, that's fine. If you say 0.8, that's fine. If you said 1, that would be a problem. And if you said like 0.1, that's a problem as well. It needs to be somewhere close to the center. Step 2 is going to be to draw your vertical line, or your vertical lines. to get 2 standard deviations for x. So we can figure out what 1 standard deviation equals. So I'm going to go to the edge of the football. These vertical lines represent the horizontal distance. Don't let that confuse you. The center, you know what? I should have said this is step 3. Step 2 should have been the point of averages. Sorry. So what we should have actually found is the center first. I'm going to say the center is about right there, which is like 82 and 75. So I'm going to say this is 82 and 75, which means this is the average x, average y. Now we're going to do the vertical distance. So we get rid of these lines so they don't confuse us. From here, this distance right here goes from about 82 to about 99. You can use 100 if you want. So that distance, 82 minus 99, or 99 minus 82 is 17. I'm going to use 18, so I'm going to change this to be 90 because I prefer not to have decimals. Okay, so 18, if I cut 18 in half, that is 9. And I can double check it. I can go this distance as well. This is approximately 66. So that distance is like 16. So it's going to be 9 or 8. Just somewhere around there. It doesn't really matter which one you use. The fact that I'm getting 2 different numbers there tells me I'm doing an approximation. It's not exact. So I'm just going to pick one of those. I'm going to stick with 9. And then I'm going to do the same thing for SD of y. I'm going to go this horizontal distance. You'll notice those 4 dashed lines make a square. Really, they should. Well, a rectangle. Sometimes it's a square, sometimes it's just a rectangle. The distance this way. So my average y I decided was 75. The distance this way, 75 to about 93. 93 minus 75 is, oh, that's also 18. So 2 SDs of y is 18, which means 1 SD of y is 9. Okay, that may have been confusing, so you might want to rewind and watch that again. We're going to check our 5-number summary versus what it actually is here, so we can see how close we were. So we guessed that the average was 82 and 75. And our standard deviation was 9 and 9 with a correlation coefficient of 7. Hey, I was off by 7 here and off by 7 here again. And that's just fine. No problems with that. If you were off by like 30, then there's a problem there. But a little bit off is not bad. It's an approximation. So looking at this, I can see maybe I should have done my middle more, not that I can get the middle, but maybe I should have done my middle more like right here, and I would have gotten closer to those points. But again, it's an approximation. We're new to this, so if you get a little bit off, no big deal there. Okay, this one wants us to guess R. We're going to do 2 things with the guessing R. I'm going to take these 4 points and ignore the correlation coefficient. And without that outlier there, sorry, I said ignore the correlation coefficient. I meant ignore the outlier. Without the outlier, I would guess that R is 0.8. With the outlier, my football shape is going to need to be something more like this. So it's going to be like 0.2. And that's why statisticians sometimes choose to throw the outlier out, even though it's not ethical, because it works their data a ton, especially their correlation coefficient. And what that means is with that outlier, the correlation coefficient is 0.2, so there's like hardly any association at all right there. We can also look at lines of best fit, and you guys have talked about it a couple times before. We'll talk about lines of best fit more in chapter 10 or 11, but without the outlier, I can draw a line of best fit that looks something like that. With the outlier, it's going to have to be something like this, because I have to keep this point in mind. So that changes the slope of that line a ton. So the main point there is outliers do affect correlation, and you have to just pay attention to that as you're looking at it. Okay, next slide. Sorry, we're already 35 minutes into this. I was hoping it would only take 40 minutes, but it's going to take a little more than that. Okay, you can calculate the correlation coefficient, and you can calculate it by hand. So to calculate it by hand, you find the average and the standard deviation of x values and the y values. So the average x, the 5-number summary basically, and then without r, and then use those to find r. So these are the steps. We're going to go through these steps. Actually, I don't want to go through the steps because there's other ways to do this. We can do this in the calculator. This is showing you what you would do to get to the correlation coefficient without a calculator. There's no reason to do it by hand though, because it's a pretty tedious process, and we can use our calculator to get there. So this just shows you the work to get that correlation coefficient. This shows you more of what's going on there. Basically, the correlation coefficient takes all of these points and how far away from the average they are, and averages them out to be 0. So you can see that more specifically here. You don't need to know those details really though. This one wants us to actually go through and calculate it by hand. I don't want to, that's a waste of our time. So instead, we are going to learn how to do correlation coefficient in our calculators. So turn your calculators on. Let me get, no. I just realized I don't have my calculator installed on this laptop. So I'm going to pause this video and get mine installed. You guys get your calculators on and we will go. Well, I just tried to install it on my laptop, and I can't because it's a district laptop and it requires an admin password, so I'll just put in a tech request. But right now, all you need to do is just follow along with these steps. Sorry, I won't be showing you guys the calculators, but the windows that you'll see are here, so you can follow along, hopefully. So your first step with calculating R in your calculator is going to be to turn the diagnostics on. What that does is it tells the calculator that it needs to be calculating R when it calculates its line of best fit. To do it, you push the button that says Mode. Mode is in the top left next to the second button, that blue button. So push Mode. And then this is where you change like all the settings. We want to change it so the stats diagnostics are on. So we're going to scroll down. You're going to have to scroll down quite a bit by just using the arrow down button. And where right now it says off, you want to change it to say on. So arrow over to on and hit enter. This shows you another way to do it. It takes way too much work. This is much easier to do it, but if your calculator happens to not have this option, this is how you do it. You go to catalog, and catalog is 0. So you press second, your blue button, and then the button 0 says catalog above it. You have to scroll all the way down a ton until you find the one that says diagnostic on, and then you just hit enter twice. So you've got two options there. Okay, then in your calculator, you're going to type things into both list 1 and list 2. So we're going to quit out of the screen we were just in by pushing second mode. Whoa, not node, mode, which is quit. And then to get into your list, you're going to go stat. And option 1, edit, and type. So we're just going to type these numbers into list 1. These are the numbers I do want you to type into list 1 so we can calculate that correlation coefficient for that. List 1 and list 2. If you need to clear out a previous list, remember you can arrow up, so you're highlighting L1, hit clear, and then arrow down. Do not hit delete. If you hit delete, it will delete that list completely, and then you have to reset your calculator. Okay, so I'm typing in my list. And before I move on to the next step, I'm going to check my list and make sure I've typed it correctly so I don't have any mistakes that affect my answer. Okay, I think we're good. Now you are going to calculate R. And to do that, you just follow these steps right here. So you push the button that says stat again. Stat is to the left of the arrows. And arrow over once to calc. Don't choose 1-bar stats. 1-bar stats gives us our average and our standard deviation. We want option 4, linear regression. What that does is it creates the equation for a line of best fit. So that's what these are right here. That's the slope and the line intercept. We don't care about that. What we want is R. So we're going to choose option 4. You can see that right here. It will pull up this window. We need to tell it to use both list 1 and list 2. So if it doesn't say that, it should just automatically say that. But if it doesn't say that, you can push second and then the button that says 1. Because above 1 it says L1. And then you can push second and then the button that says 2. And that will pull in L2. And then we just say calculate. Okay, our correlation coefficient is -0.57, and I'm going to use 2 decimal places for that. So that's how we do correlation coefficient. We'll practice this with our homework quite a bit. I will type these instructions up onto our calculator instruction sheet that you can find on Canvas. I think it's the very top module that has it. So I'll get that updated so that it includes these calculator instructions. Okay, which correlation coefficient cannot exist? And it's option E, because correlation has to be in between 1 and -1. It can equal 1 or -1, but it cannot be bigger than that. So this is a no-go. Everything else is fine though. Okay, this is your homework. It is not due Monday, March 25th. We are going to have it due on Fridays for this. So this homework assignment will be due on Friday, I think it would be March 27th. Yeah, Friday, March 27th. If I have that date wrong, sorry. It says in Canvas when it's due. All of your homework assignments, except Chapter 2, maybe I'll make one for Chapter 2 as well, can be uploaded to Canvas, so you can turn them in that way. If you download onto your phone an app called Cam Scanner, it allows you to take pictures of the pages and then put them all together into a PDF. So you can use that app or some other app, however you want, to just scan them in and get these into a PDF and then turn them into me on Canvas so I can get your grades updated during these 2 weeks, even though we won't see each other.